Hey guys, so in the first part of calculus, you might be surprised that we're going to go back to lines, but I feel like we almost have to go back and relearn or rethink about what lines mean and look like. So we need to know basically a word increment or a small movement. So anyway, increment is going to be something called delta x. So basically delta x is just how we subtract two x values, and delta y would just be subtracting two y values. And thus, when we find the slope, and we've memorized it as y2 minus y1 over x2 minus x1, I want you to start thinking it of as delta y divided by delta x. Okay? And then the point slope formula is another thing that we need to kind of familiarize ourselves with. So the point slope formula typically looks like this in most textbooks. All right, y minus y1 equals m times the quantity of x minus x1. Now, what I typically do in my class, if we've done 10 problems together, what I'll do is I'll just go ahead and solve for y. I'll say y equals m x minus x sub 1 plus y sub 1. Okay, so I like to do that, and if I need it in slope-intercept form, then all I would have to do is distribute. But this is a fine way to leave your answer either way. As well, what is also acceptable, and you'll want to know it for later in the semester for sure when we start doing integration and all that kind of good stuff. But yeah, you could also put the y1 in front if you wanted to. Okay, so let's just stick to the formula for this first example. So y, I'm going to say plus 3 because there was a minus in the formula. Y plus 3 equals the slope, negative 4, and then x minus 5. All right, and you can actually be happy about that answer. It's okay. Okay, so I want to show you how to estimate the slope of a function at a single point, because that's basically the study of calculus, okay? So by now you should know that it takes 2 points to calculate slope. For example, you cannot determine the speed of a car in front of a stop sign with a single picture. So for example, let's say that my pen is the car here, and a police officer takes a picture. Well, if he takes a picture, then all of a sudden it has stopped. If he takes a picture, then it doesn't appear that I've run the stop sign at all. It appears that I've stopped. Okay, so he actually needs more evidence. He needs at least a second picture. So what we're going to do is we are going to basically approximate what an instantaneous speed is. Okay, and the way we would do that is we would take one picture, and then we would take, so this would be our one picture, and then we would take a picture very, very close in time, and then we would measure that distance between y2 and y1. All right, so basically, let's take a look at the slope of f of x equals x squared at the point 1, 1, using all three of these approximation methods. So I'm just going to number each one of these methods, A, B, and C. So this will be A, B, and C. And I'll do my best to grab a different color. So if I'm finding the slope at 1, 1, then I would say basically that the slope equals the function at 1.01 minus the function at 1 all over 1.01 minus 1. Now, that notation, don't let that stump you up. That's function notation. I think that you should be familiar with function notation, but there is something that I need to show you on the TI-83 or 84. You see, your TI-84 understands function notation. All right, so what we're going to do is we're going to go to our y equals screen and type in x squared. We'll go back out to the home screen by pushing second quit. All right, so what we're going to do then is we're going to type in that slope formula, but I'm going to teach you some things. So push alpha F1. That will give you a fraction bar, just like that. Alpha F4 will give us the function, a selection of the functions. Now that y1 is the same thing as that y1. Okay, so back to the home screen. We're going to push alpha F4. So y1 at 1.01 minus alpha F4, enter, that's y1 at 1. So we type in the bottom part there, the denominator, and we get an estimate. Our estimate of the slope at 1, 1, the estimate of the slope at 1, 1 is about 2.01. Okay, so let's go on to option B. Option B says you can do a left-hand approximation, so go a little bit to the left. So in this case, I could do slope equals f of, well, if I took a 0.01 off, then that'd be function at 0.99 minus function at 1. And then we could do the same in the denominator, just for the x values. Now the beautiful thing about this is that I don't have to change the function any, and I don't even have to retype everything that I just typed in. I'm just going to double check. I haven't changed my function at all. And I'm just going to push up a couple of times. And then I'm going to go over to the 1.01, and I'm going to change that to 0.99, 0.99. And that'll give me my answer. My answer this time is 1.99. So if you were guessing what the instantaneous slope was, you'd probably guess 2, because I did the estimate at the right, and it's 2.01, and on the left it's 1.99, so maybe it's exactly 2. The third approach is to do a symmetric approximation. So symmetric approximation just means that we're going to go a little bit to the right and a little bit to the left. So we're going to use function notation there. So m equals f of 1.01 minus f of 0.99. And we'll do the same in the denominator. Well, the same x values in the denominator. And then we jump over to the calculator. Again, I have not changed my y equals. And I can just go up and edit what I typed before. Now, instead of changing the 0.99, you know, that order doesn't matter just as long as it's the same at the in the denominator. So maybe I'll just come in here and second insert a 0.01. And then at the back here, I'll just type in a 0.01. So that's exactly what I need. I know that the terms are switched just as long as they're consistent on top and bottom. It's good. So this time, we get the slope equals 2, and that's pretty cool. Okay, but the answer was different on 3 different approaches, and I'll tell you what we typically do. This is what your calculator uses to compute slope. Okay, you know, when it computes a derivative, it will use a symmetric difference, and the reason is because it gets to the answer a little bit quicker. Actually, the exact answer, the instantaneous slope at the point 1, 1 for this function x squared is 2. All right. However, when we're doing this by hand, oftentimes we just use the right-hand method. Okay, so it's your turn. And it says to use method 1. In other words, method A, if you want to call it that, right? So we have a funky looking function, but it really doesn't matter what function we use. So we're going to just say the slope equals g at 1.01 minus g at 1 all over 1.01 minus 1. Now some of you are saying, well, where did function f go, right? Well, there is no function f. It's named g this time. All right. Cool thing about this now is that I can't just use this screen anymore. I need to go back to y equals and change that to say e to the x. Now if you have troubles finding e to the x, you'll have to type in second and then this natural log button. Okay, second e to the x, and then actually you'll have to put an x there as well. All right, so I'm going to go back to the home screen now that I've changed my y1. And I'm going to scroll all the way up to this function where it says the function value at 1.01 minus the function value at 1. All right, so 2.732. 2.732. Now that's kind of cool that the slope actually, if you're familiar with e to the first power, that's pretty close, right? E to the first is pretty close. That's something to think about later. All right, so what about this one? Well, my work is actually going to look much the same. M equals h of 1.01 minus h of 1 all over 1.01 minus 1. Okay, so the only thing that I really have to change then is my function. So change that function to natural log x. Go back to the home screen, push up, find what you've already typed in, and push enter. 0.995. 0.995. Okay, so that is a very short explanation on basically the beginnings of calculus. You're going to need to know how to work with lines. You're going to need to know how to compute slope. And even better than that, you're going to have to compute slope, approximate it at one point. So we'll get into more as we dig into calculus.